Alright, so some points I want you to copy down from the last video here, just in general. Going uphill, alright, if you're doing that, you're gaining GPE and losing KE, so they do the opposite of each other always. You know, on a roller coaster, whenever you gain one, you lose the other. When you're going downhill, write down that you lose GPE and you gain KE. Okay, that's what we saw on this graph. You know, initially when you went downhill, you lost GPE and gained KE, right? You lost the purple line, and the green line went up when you go downhill. All right, so these are your basic rules, all right, for that, all right, that we got from the last video. All right, now I want to look at the same thing but with friction. All right, I'm going to put both three lines on the same graph with the same roller coaster we looked at last time. Now, with friction means that it's not that energy is gone totally, but it means that some of the energy of the roller coaster turns into kinetic energy. Do this with your hands real quick, or imagine doing it, and put it to your face, and the hands will feel warm. Okay, so what friction does is it changes kinetic energy of that roller coaster into heat, and the heat goes into the environment. Okay, it's no longer present as the energy's roller coaster, it's now the environment's energy instead. All right, so what happens to the total energy? Well, when we lose the energy, the line is going to look a little bit like this. Okay, so friction, let's write it down. Friction causes ET, the total energy, to decrease. It changes the kinetic energy into thermal or heat, into thermal energy, just like when you rub your hands together. Okay, now the graph is going to look pretty much the same, except friction, you know, generally just slows everything down, so the lines won't ever really get very tall here. Okay, it still starts with a lot of GPE, and to the bottom the GPE still decreases here. Okay, but as it tries to gain that GPE back, can't really go as high as it used to. So this is letter B. It has the lowest amount of GPE right there. And letter C, when it climbs that hill, it gains more back, all right? But it can't get as much back as it had when there was no friction. Now if we do the KE line, it starts at rest at 0 here. And letter A, we can write there too. Sorry, I forgot to do that. And it speeds up as it goes downhill. But with friction, it speeds up and it can't get as fast as it did last time. Last time it was able to get all the way up here, but now that the red line is going down because of friction, it can't get as fast as it used to. It still will, because there's no GPE here, it still is going to kind of basically barely just touch the red line for total energy, because the green and the purple line need to add up to the red line. So after it crosses B, it goes uphill. It's going to lose some of its speed, some of its kinetic energy, kind of like that. But it's going to lose it quite a bit now. All right. And it's going to end up much slower. All right. So the main difference is all the lines are just shifted downwards because there's less energy with friction. Okay. And especially if you just start with the total energy line, you just angle that one down because the roller coaster is losing energy, turning into heat because of friction. So the main difference is the total energy line gets angled down. We could write that here, total energy angles down. Okay, so it's going to basically look like that for total energy whenever you draw these graphs, all right, with friction.